Okay, short little video about limits at infinity. If fx is a rational number, and I'll state this out again, as a rational function of some sort, basically the concept is you've got to find the highest exponent. In this case, the highest exponent is equal to 2. So as this limit approaches infinity, this particular function approaches a over d as a horizontal asymptote. Okay? If the exponent on the numerator is bigger, the function diverges to either infinity or negative infinity. If the exponent on the bottom is bigger, it has a horizontal asymptote of 0. And I'll give you some examples. So here's one. What's the limit of this rational function as x approaches infinity? Numerator, exponent of 1. Bottom, the degree is 2. Since the denominator has a larger degree, this has a horizontal asymptote at 0. Here, g of x. Numerator's highest exponent, the degree is 2. Bottom's degree is 1. Therefore, this thing diverges since the numerator's exponent is larger. It diverges to infinity in this particular case. Okay? Unless, of course, I checked it at negative infinity, in which case I think it would go down to negative infinity because the top would still be positive, but the bottom would turn negative. Okay? A couple other examples. Look at these two degrees here. They agree. Therefore, this limit approaches 3 over 9, both positive and negative infinity, because it would be either a positive 3 over 9 or it would be a negative 3 over negative 9. Both of those are going to go to 1/3. This would be your horizontal asymptote. As we approach positive infinity here, we'd actually have to combine like terms. We see this as 4x plus 3 over x. Again, these are both to the degree of 1. Therefore, 4 over 1, this goes to a horizontal asymptote of 4. Here, same idea. Find common denominators. Once you put them together, you find out that the numerator has a larger degree than the bottom, so it diverges. And if you were checking to negative infinity on this one, you put a negative number in a cube, you get negative. You put a negative number in a square, you get positive. Therefore, negative by a positive, this actually heads towards negative infinity. Y heads towards negative infinity as x heads towards negative infinity. Okay, a couple weird ones. If you have to check inside of a rad, the square root of x squared is x, so this would be x over x, so this guy would head to 1. If it was negative infinity, it'd be negative 1 over 1, so it'd be negative 1. X minus cosine x over x. This is a little weird, but the basic concept is x gets huge, say 100. Cosine just continues to go between 1 and negative 1, 1 and negative 1, 1 and negative 1, 1 and negative 1. So it's really not going to matter to us. This gets hit to 1,000 over 1,000. That's still going to go to 1. Okay? And let's check out a couple problems here. All right, so just to kind of look at some of the problems, and you can look at some of these on your own, but basic concept is horizontal asymptote is 3. Degree is bigger in the bottom, therefore horizontal asymptote is 0. 4 sine x over x squared plus 1. Again, all this is going to do is go between 4, negative 4, 4, negative 4, 4, negative 4. The bottom's going to get really big, so the horizontal asymptote is 0. As x approaches, and oh, here we go. So looking at this one, so this is negative 6x over 4x squared. Again, just kind of concentrate. This would be 2x in the bottom. Negative 6x over 2x is going to go to negative 3. I'll let you look through a few more of those on your own, but we won't spend much time on horizontal asymptotes and limits at infinity.